used for the standard design to see if they're still below the DCD values. If that is not the case, if we observe exceedances because of the amplifications due to the higher frequency content of the input motion for the neurons, then we will perform a structural evaluation for the fire-water service complex as well, using the same finite element model that was used for the standard design, which is shown in this slide. Because the fire-water service complex, as you know, is resting on the fill concrete, block of fill concrete, we will simplify the analysis and we will use the fixed base boundary conditions rather than using springs, because the stiffness of the fill concrete is such that this assumption is reasonable. So on slide 14,
excuse me 1 second. A question on slide 13, on item 1. You're going to envelope the seismic responses with the control motion at ground and also at the bottom of the concrete fill. Was there some reason why you also didn't envelope it with the triple SI results, which you calculating anyhow, I understand?
Yes, we will calculate them. The triple SI results show small effects so far, what I have seen, but we will amplify the loads to envelope the triple SI effects as well.
Okay. Thanks.
Just to note, triple SI analysis were performed for the two cases, the lower bound and upper bound, and they are not performed for the base system.
Okay.
Now, in slide 14, I just want to present what kind of changes will be made in the FSAR to take in account the changes in the structural evaluation methodology. The first, all this structural evaluation will be documented in FSAR section 3.8, supplementing the standard design portions of the structural design, which are in the DCD Appendix 3G. Basically, we are listing the 5 different sections of this appendix which will be affected by this reevaluation, and the number of tables and figures which will be affected by the revision. Now, besides the section 3.8, where we are going to document all this site-specific structural evaluation analysis, in section 5, extra section 3.72 should be also revised, where we are going to delete all discussion related to the scaling factor method, which will be outdated, and 372 as a section will only present the comparison of site-specific seismic loads and standard design loads. And we will have consistent information added to link it to the structural evaluation done, documented in EFSAR section 3.8. So I think this is the last slide from the presentation regarding the proposed structural evaluation. And if there are any questions or comments,
I have a question on the last bullet on that page. What is TRACG?
Taylor, you know what it is?
Bullet?
I don't. Jonathan, are you still on the phone?
TRACG calculated loci.
Okay. Cool.
So Taylor, do you want me to just say what it is?
Yes.
It's the track G LOCA analysis. It's the consequences of the LOCA.
That will be revised also because you consider earthquake or has earthquake?
Yes. Yes, we do. Some of our load combinations include seismic and these accident temperature cases.
Okay. Okay. And where would be the the fuel rack and stuff like that? That will be in 3G3 on 19th.
We have those in a separate REI.
Yeah. All right.
DCD fuel rises.
You can check out topical report. Somewhere else, it's not in
chapter 9.
chapter 9.
I mean, the structural evaluation is not directly related. I mean, whatever I was talking to the racks evaluation.
Okay.
Fuel.
Okay. I don't have anybody else has any comment on this? This concludes
Nope.
17. Which to me, I think pretty much what we discussed at the last public meeting that has been incorporated in the plan. It would be nice, putting all together in a plan and schedule and when things when things will be received, and also some results of intermediate if you have completed something.
Yeah, Meadows, we are working on the plan even as we speak, and we'll get that to you as soon as we can. We understand that would be helpful to you.
Yeah, okay.
Yes, I'll just leave it at that.
This is Perry Buckwood. We've come to a kind of an intermediate point in the presentation, and also we've come to 4:30 p.m. The public meeting was scheduled officially from 3:30 to 4:30, but unless there's any negative response, I figure we'll just move on and complete the presentations. At this point, we'll go a little over. Is that okay with everybody?
Okay with me.
Did the public still get a chance to speak afterwards, Perry?
Yes, you will, of course.
Thank you.
Please continue.
Okay, now I'm on slide 15. This part of the presentation is related to the modeling of the fuel extent in our analysis. But first I want to give you a brief background how the ESBWR plant will be constructed in North Anna. Prior to the construction of the reactor building, fuel building, and control building, the in-situ materials will be excavated down to zone 3-4 rock, which is a sound rock, to make sure that all these structures will be supported by a sound rock material. Now the excavation will be secured by the sheet piles around the parameter. The excavated material around these two buildings will be replaced, backfilled with a concrete fill to replace the zone 3 or weathered rock material, and above the rock surface, engineered fill will be used up to the plan grade. Now, depending on the plant configuration, on the subgrade variations for the site and the construction demand, extent of these fuel materials around the reactor building, fuel building, and the control building will vary. Basic and horizontal extent, the variations go from 3.1 meters to up to 17 meters. Also, there are variation in the depth of these fuel materials regarding where is the location of the rock surface. So basically, what we will have in the real site condition, there will be a lot of variation, both in horizontal and vertical extent of the fuel material. We can go to slide number 16. I will discuss a little bit the naming properties of the fuel materials with respect to the in-situ material. In this slide, I show 4 plots which compare the shear wave velocity and the damping of the concrete fuel material with the rock material, as well compares the shear wave velocity and damping of the engineered fuel with the in-situ soil. What can be observed or concluded from this plot, you can see that the concrete fuel has a higher stiffness and lower damping than surrounding rated rock. On the other hand, the engineered fill has a lower stiffness and higher damping than surrounding in situ soil. Next slide. Furthermore, elaborating on this issue is that we are providing calculation of the shear column frequencies for both materials, in situ and fill material. So basically the natural frequencies and the average shear wave velocities of the pixel and in situ soil show that the rock has much higher frequencies. The concrete fill is much stiffer than the in situ rock, and on the other side, the engineered fill is softer and has a lower frequencies than the in situ saprolite. The next slide, number 17. Now, the input we use for the soil structure interaction analysis comes from the site response analysis that were performed on a randomized profiles. There were two sets of profiles used for this purpose, as Alidat described during the last meeting. The first set of response analysis was performed on profiles representing in situ properties of the in situ material. This site response analysis provided the site amplification factors that were used for development of design ground motion spectra, the FIRST and the GMRS. Besides that, the results of this analysis were used to develop profiles, set of 3 profiles, lower bound, base estimate, and an upper bound, that will capture the variation of the properties of the in situ materials, substrate materials. In the SSI analysis, we use these properties, we assign them to the far field elements, or in the SASI, in the site module. Now, besides these far field elements, we used near field elements. These properties were also obtained from site response analysis in the same manner as the in situ properties. By running site response analysis on the profiles that include fill concrete and engineered backfill. And we also developed 3 sets of properties: lower bound, base estimate, and upper bound. And as I said, these properties are assigned to the elements in the house model, which are shown in the next slide, slide number 19 for the reactor building, fuel building. Just as a reminder, we run 2 sets of analysis. One is the partially embedded models, where we consider the building embedded only in rock and surrounded by fill concrete. Besides that, we run 3 more soil cases where we consider the building fully embedded in rock and fill concrete, as well as the in situ soil and engineered fill. These are the structural models, which show the structural model plus the near field elements. The extent of the elements used for the analysis of reactor building, fuel building, is around 3 meters. And this value of 3 meters is the lower bound value of the fill extent, of the horizontal fill extent, and is determined as a half of the distance between the reactor building, fuel building, and the turbine building. Now the next slide, which is slide number 20, shows the same thing for the control building. And here, the only difference than the lower bound value for the fill extent is 3.73 meters, almost 4 meters. And this was found, was calculated as the half distance between the control building and the service building. Now, the control building model, just as a reminder, also includes approximately 5 meters thick concrete field block below the basement as a near field solid element. On the next slide, 21, we show how we are going to model the backfill materials in the soil structure interaction analysis of the reactor building and control building. As you can see in the plots, we run two sets of analysis, one partially embedded and one fully embedded. And for both of them, we considered the fill only around the control building because this analysis, the focus of this analysis is how the heavy reactor building affects the seismic response of the much lighter control building. So in order to make this analysis feasible, because the models are quite big, as you can see, we have excluded the fill materials around the reactor building because their effect on the control building response will be small. Now, the extent of these near field elements around the control building is the same as what was used for the standalone analysis. It is 3.73 meters. Now, the concrete fill around between the control building, fuel building, control building, and reactor building is explicitly modeled, as well as the tunnel, which is located above this concrete fill layer. So, in order to accurately capture the effects of interaction between these two buildings. In the next slide, number 22, you can see the model we use for analysis of the triple set SI analysis of control building and site water service complex. And here we also include near field elements to consider concrete field and engineered field. First, we consider the concrete field block below the fire water service complex as shown in red. And also we show the concrete fill and the engineered fill around the buildings. The extent of this concrete fill, the extent of the backfill near field element is the same as the standalone control building model, which is 3.73 meters. And between the buildings, to accurately capture the interaction of the or the effect of the concrete fill block below the fire water service complex, we accurately model the fill concrete extent and the concrete fill extent. Now the next slide, number 23. I will discuss why the approach we have taken is adequate. First, I want to remind you that our design will be based on envelope of responses obtained from site-specific SSI analysis of partially and fully embedded models. That the boundary variations of the subway stiffness or the embedment and related to backfill horizontal extent or even also bound effects of soil separation of the at the top of the structures. Now, the fully embedded model represents upper bound stiffness of the embedment. Why? Because the engineered fill has lower stiffness, and considering lower bound extent of the near field elements, we are maximizing the stiffness of the embedment. On the other hand, the partially embedded model represent the lower bound stiffness, or the extreme of the lower bound stiffness, where we don't consider even having any soil there. So basically, by enveloping those three results, the results from the two cases partially embedded and fully embedded. We consider two bounding stiffness cases, and we will envelope any possible variation of the field extent on the seismic response of the building. Now, triple SI analysis, as I discussed before, try accurately to capture the actual configuration of the site between the two buildings. So they will also give us accurate effects of the structure-solid-structure interaction. So based on this argument, we deem that our consideration of the horizontal backfill is adequate, and it will capture the variations that are possible in the North Anna site. I think this is the last slide of my presentation. Now we can go with the questions, which is slide number 4.
I don't have any question on this. Does BNL have any question?
No, we don't.
I think that was, I find that whatever we discussed has been reasonably, actually adequately captured. So, so all we
And this is Gina. I'm sorry. Could you speak a little more loudly, please?
Well, all I'm saying is that what we have discussed during the public meeting last time has been adequately captured in this plan. So that's good.
Excellent. Thank you.
If you have time, I want to put two comments, on the responses so far that we have looked at.
Okay.
Some feedback, one of them, first one is the 371-12.
Okay.
Which involves from our part asking for time history, generation, and looking for some power spectral density function. Now, we looked at the power spectral density function that you have provided in your response. Now, we fully do not understand, first of all, how you developed those power spectral density function for that time history. What was the duration and what method you used. And the second thing is you indicated in the response that based on the observed range of these amplitude variations, that is less than a factor of about 10 to 25 above or below the average PSD values across the frequency range. Or in other words, you are saying it's within maybe 10 to 25% of the average PSD. Now, I also could not determine what is the average PSD value here. And the third thing is the figures show, particularly, for example, figure 12 of that response, it shows that at one of the frequencies, the dip appeared to me, quite substantial. So how did we really demonstrate that we don't have any deficiency in the frequency of the of power in that region? So you can think about it.
Okay.
And we need a little bit more basis for concluding that it doesn't have any significant deficiencies or gap in the frequencies.
Okay.
That one, and the other comment that I have, which really I'm not asking any new information, but we looked at the transfer functions on some of those. I think that was let me see first. The II is 372-15. In that response, we requested the transfer functions, to see how that looks like. Now we observed some phenomenon there which we don't understand, so you may think about looking at it. These we'll be discussing this during the audit. Okay, but like there's a peak, and the peak is not even being controlled within the figure. It goes on and on. beyond the figure. And it was which some of those we really didn't understand those peaks.
Okay.
I mean, I can explain that the large peaks are occurring where they are representing the shear count frequencies of the embedment, basically, and you have dips in the input motion at the same frequencies. They were truncated in the figures in order to make the other peaks more visible. But I mean, the transfer functions have the
Okay, all those things we'll be discussing, just basically understanding, that they are okay. This is not something else, coming into the computer. This will also, we'll have to, when we look at those, the verification of the FAST program and all those things will be kind of related. BNL, do you have any other?
Manus, did you ask us? Could you say that again?
That's the only two right now, and then we'll look at some other RAI responses, and if we have any comment, we'll put it down on paper and give it to Terry.
Yeah, one other thing.
1 second, Manus, one more.
Yeah, one other thing regarding the transfer functions. We also noticed that there were some pretty large peaks right at the cutoff frequency in some of the transfer functions. So we wanted to perhaps discuss those to see what's the physical significance of those.
Especially in the horizontal direction. Those are close, right?
Well, it's the one which I think you just cut off the transfer function at 50 hertz, and the question is, by cutting it off where it's, at the peak or approaching the peak, are you losing out some of the energy beyond that may contribute, or you're not?
I mean, we are cutting the frequency up to 50 hertz, using the SRP standard. We may provide you we can extend to higher frequency to show what is the effect.
That's the kind of thing we're looking for. Yeah.
Right.
Do it for upper bound or stuff.
Do you have any significant power beyond that frequency, in the earthquake cumulative power, or 90% or 80% is captured?
Right, they're quite high. They're not 100%, but they're like 80-90%, depending on the direction of the motion and different soil profiles, because we have within motion, and we have all that information available.
Yeah. Okay. I think these are the topics for probably we have to make sure we understand during the audit all these things.
Right. I mean, but short of that, these are topics we can discuss in a future conference call. Yeah. If the clarification or explanation can be provided that may or may not be adequate, and then the possibility of a revised response way before the audit. Well, starting August on that.
Complete review of the RL responses is good, but maybe minus can put them in feedback.
Yeah, we'll put
this is preliminary.
Comment, yeah.
Okay, gotcha.
So that they can provide time to feedback to me and for people to consider, this will have some suggestions.
Right, and looking at the schedule, well, we're all on the same page as far as Dominion submitting their milestone and schedule in the short term, and if revised responses are needed, it could be something that drops into the audit. We'll figure it out one step at a time, but I guess just continue reviewing, and so far these are preliminary comments.
That's right.
Any more questions, NRC or Dominion or Brookhaven? We can go to public questions if not. So let's move on to the last phase of the meeting and query the members of the public for any questions specifically relevant to the RAIs discussed in the presentation related to the seismic review. Any questions?
Yeah, hi, Perry. This is Erica from Henrico.
Hi, Erica.
Hi. So, is Alice, what's her name, Alice, that was on the last call talking about the seismic issues? Is she on today?
No, she's not involved with the specific seismic review. She's a Chapter 2 person, hydrology, geology. But
okay, so she was bringing up issues that weren't really I guess there was no conclusions on that, and I guess I was just wondering if she was on the call. So I guess maybe I'll have to get with you, Perry, so I can get in touch with her.